Hello students, in the previous video we have seen what is work energy principle, right? So in this video we are going to study what are the different forces which can do the work, what are the forces which does no work, and what are conservative and non-conservative forces, and what is the principle of conservation of energy, right? So what is work energy principle? Change in kinetic energy is equal to work done. So you can write KE2 minus KE1 is equal to work done between 1 and 2. That is work energy principle. Change in kinetic energy, final kinetic energy minus initial kinetic energy, is equal to the work done, total work done between the positions 1 and 2, means work done by all the forces acting in the system. So what are those forces which can do the work? So in engineering mechanics we come across these types of forces: applied force, frictional force, gravity force, and spring force. So we came across these four types of forces. Now what is work done by applied force? So the work done by applied force is given by force into displacement. If the force is acting on the body and the body is having displacement, the product of force and the displacement in the direction of the force is known as applied force. If the displacement is in the direction of force applied, then the work done is said to be positive. If the displacement is in the opposite direction of the force applied, then the work is said to be negative by that applied force. If the applied force is variable, then the work done by the applied force is, so integration of F ds, right? Now work done by friction force. Work done by friction force is always negative because the friction force will act in the opposite direction of displacement of the body, in the opposite direction of motion of the body. So work done by the friction force is given as minus the magnitude of friction force into the displacement. So what is the magnitude of friction force? Coefficient of friction into normal reaction into the displacement. Here which coefficient of friction you have to consider? Coefficient of static friction or coefficient of kinetic friction? It should be coefficient of kinetic friction. If it is static friction, that means there is no relative motion between the two bodies. Hence, there is no work done by the friction force, being there is no displacement. Understood? So, work done by friction force is minus mu k into normal reaction, that is the magnitude of friction force, into the displacement. Whereas, work done by gravity force, it is given by mg h. Mg is the gravity force, weight of the body, and h is the vertical displacement. If the body is moving upwards against the gravity, then the work done by gravity force is negative. Gravity force always acts vertically down. If the body is having upward displacement, here displacement is in the opposite direction of the force, so the work done is negative. If the body is falling down, then the gravity force is acting vertically downwards and the displacement of the body is also downwards. So the displacement is in the direction of the gravity force. Then the work done by the gravity force is positive, right? Now work done by spring force. Work done by spring force is given by K by 2 into x1 square minus x2 square. Here K is the stiffness of the spring, force per unit deformation, Newton per meter or millimeter, x1 is deformation of the spring in the first position, x2 is the deformation of the spring in the second position, right? So this derivation, work done by spring force, that we will see in the next video. Okay. Now what are the forces which does no work? So what are the forces which cannot do any work? Tension in the string, because it is the internal force, right? So the work done by tension in the string is always 0, because in the string if there is a tension, suppose say this system is moving towards right and these two bodies are connected by a string. So if you consider any point on the string, for body A the tension is acting towards right, and for body B the tension is acting towards left, right? And if the system is having displacement, say x towards right, then work done by this tension of body A is positive, say T into x. Work done by this tension of body B is negative. Here tension is acting in the opposite direction of displacement. Again it is T into x. But the resultant work done is 0. Being this tension is internal to the system, work done by tension is always 0. And second, work done by normal force. Work done by normal reaction, it is always 0. Because body is not having any displacement in the normal direction. Suppose if the body is moving horizontally on a plane, so the weight of the body is acting vertically downwards, the normal reaction offered by the surface on the body is upwards. So the body is having horizontal displacement. There is no displacement in the direction of normal reaction. Hence work done by normal force is always 0. If the body is moving along a curved path, then it is subjected to two types of forces. The tangential force Ft, that is m into at, tangential component of acceleration, and normal force, that is Fm, m into an, that is normal component of acceleration. So as the body is having displacement along the curve, there is no displacement in normal direction. Hence the work done by this normal force is always 0. If the body is moving horizontally, then work done by the gravity force is again 0, because there is no displacement in the vertical direction when the body is moving horizontally. And the work done by the reactions which are acting at the supports are always 0, being the support is not having any displacement. As the force is acting on the support, displacement of the support is 0, therefore work done by that force is 0. Understood? Then conservative and non-conservative forces. If the work done by the body, by the force, if the work done by the force is independent of the path of the motion of the body, then it is known as conservative force. If the work done by the force is dependent on the path of the body, then it is known as non-conservative force. The example for conservative force is the gravity force or spring force. It is independent of the path followed by the body. Suppose if a body is sliding down the plane, so it is having displacement along the plane. Say it is position 1, position 2. So the gravity force, it is acting vertically downwards, and the vertical displacement from position 2 to position 1 to 2 is say h. Then work done by the gravity force, it is mg into h. H is the vertical displacement. So it is independent of the path followed by the body, right? It is simply the vertical displacement between the initial and final position. So it is a conservative force. So if you consider work done by friction force. So the friction, it always acts in the opposite direction of displacement. So it is a friction force. It is having displacement down the plane and friction force is acting up the plane. So the work done by friction force is, so it is friction force into displacement. So it depends on the path followed by the body. So it is non-conservative force. Is it clear? Simply, conservative force is the force where the work done by that force is independent of the path followed by the body, and a non-conservative force is the force in which the work done by that force is dependent of the path followed by the body. Principle of conservation of energy. So what is law of conservation of energy? Energy can neither be created nor destroyed. Is the total energy of the system remains constant. Here we are considering mainly the mechanical energy, that is the potential energy and kinetic energy. So as per principle of conservation of energy, the sum of potential and kinetic energy of the system remains constant. So potential energy plus kinetic energy at position 1 is equal to potential energy plus kinetic energy in position 2. So the total mechanical energy remains constant, known as principle of conservation of energy. Suppose if there is a friction in the system, we cannot use this principle. Because of friction, there is a loss of energy in the form of heat. So the principle of conservation of energy is not applicable there. Is it clear? Thank you.